even if we say that Newton and Leibniz did some similar things, so we can credit both of them with the discovery of calculus, they were not exactly the same. Whereas, if you see Madhav's science series and Newton's, they are exactly the same. And if you see the Yukti Deepika and Leibniz, they are exactly the same.
Hmm.
So that is what makes this whole thing into a very clear case of robbery and thievery.
Hi, everyone. Welcome back to the WAF Indian History Podcast. I'm Utkarsh.
Namaskar, Sumedha here.
Good. So, we started off a very, very interesting discussion the last time. And the
Yes.
discussion was so interesting that we could not finish it.
Yes. There was
It
too
was
much
one of those
material.
things. Yeah. So, for those of you who did not watch the last one, first question, why didn't you watch it now? No, I'm just joking. But no, we started the discussion on mathematics and India's contribution and ancient Indian mathematics. That's what we started the discussion on. We went through numerals, we went through a little bit of zero last time, we went through a lot of what happened in Europe in the Middle Ages, or rather slightly before the Middle Ages. Fascinating conversation. I learned so much. So do watch that if that interests you. Uh, but today we're going to talk about probably my least favorite mathematical concept, something that haunted me when I first studied it. It haunted me through college. And I'm a person who loved math, right? Math, and even now, I mean, I don't like calculators. I keep doing mental math. I don't have Excel sheets. I keep doing mental math all the time. But calculus was something I could never quite love the way I just loved general arithmetic and all of that. So we're going to talk about that. And I believe you have a very interesting perspective on calculus, isn't it?
Yes. And also, Utkarsh, like I told you last time, there's perhaps a very good reason why you don't like calculus. And that reason is that the people who stole it could not understand it, put a few patches on it and have used it, but have never really got to the basics. Therefore, they are not able to disseminate it in a simple and very easy to understand manner. So, this has been the theory of C.K. Raju, the very famous computer scientist and mathematician. He is a great campaigner on this. But now I've said something which I ought to prove, oughtn't I? Stole the calculus. So, what do I mean by that? I'm sure you want to know. And there will be a lot of outrage on the part of
Mm-hmm.
perhaps many listeners and other people. What is this stealing of calculus? In fact, a little anecdote, not a personal one. But remember
Mm-hmm.
that book I showed you last time, The Crest of the Peacock?
Yes.
Huh? So the author of The Crest of the Peacock writes a few years later that I wrote a number of things in that book. But when and where I wrote that calculus had its origins in India created the greatest ripples in the mathematical establishment, and I was repeatedly charged with trying to discredit Newton and trying to discredit Leibniz, and it created a huge kerfuffle in the mathematical pond. So in fact he went on to write a number of other books on this subject. And apart from him, of course, many other people have written many other things on this, and I'll try and take you through this. So remember the names of Bhaskar Kamble and C.K. Raju, and I've put them all in the description. I've also referred to a few other papers and books. I'll put those too in the description because this is a story which goes back, perhaps 1500 years. It's not a very recent kind of development. So, why this excitement about calculus must be Western? Why is
Mm-hmm.
it so much a foundational part of how Western mathematicians and the West actually see themselves? So, that is because the beginnings of modern math, and I don't mean modern math as in sets, etc., but the modern way of doing mathematics in the 17th century stood on the discovery of general algorithms of calculus. One, and
Okay.
two, the discovery and application of infinite series. So technically, this was 200 years before the Europeans did it. Many of the people who have studied Indian math say that this was there in India. The roots were in the Kerala school of mathematics, which I'll talk about a little more. But you see, that is the reason why it gets so argumentative, and Western mathematicians get so angry about it because it is foundational. It is
Mm-hmm.
that on which their ideas of the superiority of the European mind rest. So if you
Mm-hmm.
say that that was not original and that came from somewhere else, they don't like it.
But just to understand it better, there are certain things in the accepted scientific view where it's very clear it did not happen first in Europe. Like people are clear, say, in terms about what the timing of the Assyrian Empire, for example, is using a very random example, right? It was clearly more advanced than what Europe was at that point in time. It's well accepted in the popular view. Given that you do have, I'm assuming you will tell us about it, but I'm assuming you do have calculus or something similar to calculus or something better than calculus in documented as part of Indian mathematics with a long lineage stretching thousands of years. Why the hesitation to accept that?
One, of course, Utkarsh, is that, people don't care about the Assyrian Empire any longer. Today, they still care a lot about calculus, and they care about the scientific revolution, the so-called scientific
Mm-hmm.
revolution in Europe, which, that post-Enlightenment scientific revolution, the modern persona of the scientific, rational European man, all these are very
Mm-hmm.
intimately connected with their ideas of how this whole area of math developed. And remember that it's also connected to some other things. What are those things? Why do we get excited about calculus anyway? Because we need it for two, three very important things. One is navigation. Two is making of calendars, and three is practical math. So if you remember the podcast, and viewers, if you remember the podcast we did on the Gregorian calendar, the reform of the Julian calendar, that's connected
Mm-hmm.
to this. So calendars and navigation. What is navigation connected with? It's connected with colonization, with Christianization of the world, with the extension of the power of the church, with the extension of the power of the Christian world. And all these boil down to calculus, because without it, they would not have been able to do all this. So is it
Mm-hmm.
that all these, what was it, Niall Ferguson, he has called the killer apps of Western civilization? Is it that so many of these things were actually not killer apps of the Western civilization, but actually stolen from somewhere else? So all these things are, really, really connected to each other.
Mm-hmm.
And therefore,
Mm-hmm.
it hits at the superiority, the deemed superiority of European mathematics. And again, remember all those very typical things, that the Asian mind is very mystic. It cannot do rational things. It cannot do math. It cannot do science. And I really hope to take up the bit on the Asian mind, the Indian mind, and science also at some point of time. So it's
Okay.
all kind of in a package. All these
Mm-hmm.
things are kind of put together in a package, and it's the defense is of that whole superiority and extension of Western civilization, the methods of colonization, methods of navigation, etc., all of which happened 16th, 17th, 18th, 19th centuries. Now,
Okay, I see.
I'll just give you a little bit of a, you know, story on navigation. So Vasco da Gama had to find a way to come to India, because for the previous thousands of years, trade had been there between the Indian subcontinent and Europe via the Gulf. Last
Yep.
time we showed a map about how it happened. And I had
Yep.
also mentioned that the fall of Constantinople actually blocked that, because
Hmm.
then the free flow was stopped. So if the free flow is stopped on that route, then you have to look for some other route. But how do you look for another route? Because your navigation systems, your ideas about navigation are very crude. You are not able to do
Hmm.
that. So the
Hmm.
story that we have been taught is that Vasco da Gama was a master navigator. He found that route. Did he really find that route? Again, I would invite viewers to read the translations of Vasco da Gama's journal, his own journal, which he kept at the time when he was doing that journey. So he did it with the help of somebody who he actually, a Hindu sailor who he more or less kidnapped and forced to tell him the way to actually reach Calicut. So
Hmm.
he reached Calicut, and it is from here, remember this place and this name, because it is from here that a lot of the transmission of theories of calculus and math and calendars went from the Kerala school of mathematicians to Europe, to Rome. Actually, there was a kind of direct route between Calicut and Rome.
That's
So,
a unfortunate coincidence that the port of call is also the port where you have the School of Mathematics. If
no,
only the
no,
School of Mathematics.
no, but maybe, but perhaps not, because what happened actually was a little earlier, Francis Xavier had also arrived in Goa. When he arrived in
Okay.
Goa, a lot of Jesuits arrived with him and they spread out.
Okay.
So they were tasked by the church with
Hmm.
finding out whatever knowledge, information they could from this country and to bring it back for the use of the church. Last time or before that, Utkarsh, I think you had raised a question about that the church itself was very anti science. So, how could it
Hmm.
be that it was actually doing something for math and science, whereas it was actually very anti science? So, the answer to that is that the church was not anti science per se, it was only for itself, especially the Catholic Church. So if it could
Hmm.
get any scientific principles or mathematical principles which would help it in extending its power, well and good. But if there was anything which would undercut the power of the church, then they didn't want it. So it was
Hmm.
like a kind of hegemony, the control of
Hmm.
math and science, which is why even today a lot of people think that religion as they understand it and science and math as they understand it are different from each other. This is because of the
Hmm.
stand of the Catholic Church. It's not true for all religions in the world,
Hmm.
but it was
Hmm.
definitely true for the Catholic Church. So there were Portuguese mathematicians such as Pedro Nunes. Pedro Nunes, his name is very important in this because he did a lot of stuff. He had a direct route to Calicut, which is in Kerala. The first batch of trained Jesuit missionaries arrived in 1578 in Calicut, and these were trained mathematicians. So, who were these? I'll give you some names which are very important: Matteo Ricci, Johann Schreck, Antonio Rubino, and there is the existence of letters which were sent by these people from India to Rome. There was a Collegio Romana. So this place was a center of studying, etc. in for the Catholic Church. So there is a lot of to and fro. There are a lot of letters, especially the letters of Matteo Ricci are very much available today to read, where he says that I have come here to look for a learned Brahmin who can teach me mathematics. I am paraphrasing. He, of course, wrote in a
Hmm.
different language and in a much more long-winded way, but I am paraphrasing. So they were looking for this information. Then there was
Hmm.
a person who was a kind of center of dissemination. He was a mathematician who was a monk. His name was
Hmm.
Marine Mersenne. So Marine Mersenne then would disseminate this through his correspondence and through his discussions with all different other people who were in the same area, same intellectual area. He would disseminate all this information. So now you can see that the path of dissemination is clear. The Jesuits have arrived. They are in Kerala. There is a Kerala school of math. They are picking up information from there and sending it back. I've told you about one part of it, which is the mathematicians who are the trained Jesuit mathematicians who
Hmm.
arrived.
Hmm.
Now, the
Hmm.
other
Hmm.
part is, of course, the Kerala school. So, what is this Kerala school of astronomy, or what is this Kerala school of math? So, it is actually, it is called the Kerala school of mathematics as well as astronomy. And the most famous figure in this is Madhavacharya. Again, I will let me show you a little picture, and this we can put this later. These are the names of some important people. I will tell you the names of other important people too. So I am hoping that this will be a little visible. If it's not, we shall see it again. You can put it later. So group, this group of mathematicians were all between the main ones were between the 14th and the 16th century. This is the well recognized Kerala school with the person who is originating all this. He's called Madhavacharya. He was called the Madhav who knows all about spheres. That was his name in Sanskrit. The
Hmm.
Madhav who knows
Hmm.
all about spheres. So Madhavacharya had his own disciples. They had their own disciples because, again, as you will remember, in India we had the Guru Shishya Parampara. So we talk of Madhav, who was born in 1340. Then his Shishya was Parameshwar. His Shishya was Damodar. His Shishya was Neelkant. And this Neelkant Somayaji, remember his name. Remember the name of Madhavacharya and also of Neelkant Somayaji, because a lot has been stolen from these two people. Then you had Jeshtadev, then you had Achyut Pisaratti, Chitrabhanu, Shankar Variyar. Why am I taking these names, Utkarsh? Because if we know the names of Newton and Leibniz, we should also know the names of these mathematicians. And they tend to get subsumed in some story. Oh, there were some people in Kerala who were doing something. No, they were very, very important mathematicians, and there should be stories about them, just like Newton's apple. I think that's where we've lost out. We've not, they are not people until they are people in whom others can be interested. Their stories are inspirational. How will this
Hmm.
whole story get out to everyone? So, these were people who were doing something, who were studying. They had lives, they had very interesting lives. So, the important thing about them is that they all belonged to temples. So the whole group of mathematicians, the names that I told you and other names which I will tell you, they were either Brahmins who were living and working in those temples, or they were from the other castes who did other things in the temple, for the upkeep of the temple. So
Hmm.
they were a mixture of castes, but they were all Vaishnavas. What is Vaishnavas? They all believed in Lord Vishnu. In fact, I told you about Achyut Pisaratti just now. His disciple, Narayan Bhattathiri. There is a very, very sweet story about him. So, Achyut Pisaratti used to suffer from rheumatism and he was crippled by it. So, his Shishya was very, very sad about this and he prayed to Lord Vishnu that Narayan Bhattathiri, he should get the rheumatism and his guru should be spared. So apparently that happened. He was struck by rheumatism. And then, he went and surrendered himself to Lord Vishnu. And he has written some beautiful, beautiful odes and hymns to Lord Vishnu. One of them, the Narayaniyam, is still sung even today. The point of this little anecdote is that devotion to God and math are not mutually exclusive. They are not at all mutually exclusive. So all the mathematicians from the Kerala school were devout Nambudiri Brahmins or some of the other castes that I told you about, and they were very devout Vaishnavas. So we'll have to throw out that story which says that religion and science are at loggerheads. So, I mean, is this
Hmm.
making sense to you, Utkarsh? The difference in the, social model, so to speak.
Yeah, I think the loggerheads of religion and science is very, very specific to some of the clashes that happened in, I would say, Europe and Central Asia. Because I think there you've got a very different. I mean, my whole understanding from all of the podcasts that we've been through is that religion, in terms of the way you think of it from an Abrahamic sense, is not necessarily an
Mm.
accurate way to describe the relationship with people in the subcontinent and their metaphysical understanding. I mean, it's not, I
Yes.
think here
Yes.
you don't have a separation of religion, science, philosophy. It's all part of the same understanding,
Yes. Yes.
right? That's the
True.
key thing I've understood, at least so far.
Yes, yes. And so many of these things. So the rational method says that you can gain mastery in a subject, you study it, you learn it, you keep practicing it, etc. But there are also other models wherein you see something. A lot of our Vedic rishis, they are called drashtas because they saw the knowledge in front of them. And it's true
Mm-hmm.
even of certain stories about Western scientists. But let me give you some Indian examples. For
Mm-hmm.
instance, Adi Shankaracharya, he had a
Mm-hmm.
shishya who was really, really dumb. And Adi Shankaracharya at that time had the most brilliant minds in the Indian subcontinent in his ashram. So his other shishyas used to really think that this Totak, his name was Totak, that he is really stupid and dumb. But he had one thing which was unwavering, his belief in his guru. So it is
Mm-hmm.
said that one day he had gone to wash the clothes of his guru to the river. He had gone to the river. All the others were in the ashram with the guru. And at that ghat, he suddenly had a vision and he suddenly had an understanding of knowledge, and then he composed some things which are still held in great esteem today. So his name is Totakacharya, and his we study his compositions today. So this person who was completely dumb, through his devotion to his guru, he got knowledge in some strange way which we do not understand. We laugh at it, that this is all superstition and this is nonsense. How can anybody just learn something and start writing about it immediately? But it happens. And I don't know whether we will be able to talk about him today, but we definitely must sometime. Srinivas Ramanujan, you know that
Mm-hmm.
he is perhaps the most brilliant mathematical mind of the 19th 20th centuries anywhere. So he
Mm-hmm.
always said that it was his Kul Devi who used to come and tell him the math. And his ideas, his mathematical notations, etc., his famous diary, Ramanujan's diary, has not yet been
Mm-hmm.
deciphered completely. People are still
Okay.
deciphering things. So Ramanujan is an amazing example of Indian math, and I suppose we'll look at him some other time, but I have digressed. Let me go
I think
back
inspiration
to.
coming from nothing, or from not from nothing, but not necessarily coming from yourself, is it might be more difficult to think of or imagine in a scientific idea context, but in a creative context, it's fairly standard. You know,
In a
I mean,
creative
any.
context, it's standard, Utkarsh. But again, as you
Hmm.
said, in the science, math kind of basket, this is not at all common. But you
Hmm.
think of periodic tables are those? Mendeleev. Whose periodic tables are those? I am not a science student, but
And
he
I,
also.
yeah, go ahead.
Anyway, so but anyway, what I wanted to say was he also set down those tables through his own understanding and through his own vision
Hmm.
of what it should be. And his confidence was such that he said that all the gaps in my formulation will be filled in by future discoveries. And they were.
Discoveries. Yeah.
Yeah, and
Yeah.
they were. So, this whole idea of religion and science being opposed to
Hmm.
each other is something that is completely negated by the Kerala school of mathematicians. The Kerala
Hmm.
school of mathematicians is normally said to have, existed between the 14th and the 16th century. However, it is true that this Kerala school actually took the ideas of Aryabhatta. You remember the Aryabhatta of the 4th century. So
Of
there was
course.
a group between them. So they were the Aryabhattian school of Kerala mathematics, so to speak, because they built on his work. So we
Mm-hmm.
cannot really say that this Kerala school suddenly came up in the 14th century and then it was there till the 16th century and that's it. It wasn't like that. There were antecedents, there were roots, there were things that they were building on. And they built on it for a good 1,000 years or more. The first legendary founder of this Kerala school, if we look at it in the expanded way, he is somebody called Vararuchi, who lived in the 4th century. And then, there is a list of about 10 to 15 of them. Either I want to read all of them out or I want to put them on the screen, whichever you like, because I want these names to be recognized. We cannot let them languish in, complete, what can I say, darkness. Nobody knows their
Mm-hmm.
names. And these are the people who have been luminaries of math in the centuries which have gone by. We have completely forgotten them. It is time to bring their names out again and to know them for the brilliant minds that they were. So you had Vararuchi, Haridatt, Govinda Swami, Shankar Narayan, Uday Divakar, Achyut, Keralacharya, Vyagrapad, Krishnacharya. Krishna, this is interesting. Krishna Acharya, that means the Guru, and Krishna
Mm-hmm.
Shishya, which means that he was the person who was the disciple of Krishnacharya. Then you have
Mm-hmm.
Suryadev Yajvan, Vidya Madhav, Vishnu Neelman, Govind Bhattarai, Tamara Nallur, Nitya Prakash, Kumar Ganak, Rudra Van. And after Rudra Van comes Madhav, who is the most famous person. That is
Mm-hmm.
Madhavacharya. And I've already told you the names of his Shishyas. So we need to know these names. We need to know these stories. At some point of time, maybe, we should pick up these people and do podcasts on them. The story of Madhav, the story of Nilkant Somaiya. So we need to do all these stories so that they also become household names, at least in India. In actual fact, they should be household names everywhere. We have a very interested podcast viewer. He comments by the name of Jeremy Mansouri. So he asked a question on the last one. How can I learn Vedic mathematics? I know only English. So I have written back to him and I want to say this here also that a lot of the math you do already has Vedic roots. So Vedic math is not something else. The sine,
Mm-hmm.
cos, tan you're doing, that is Vedic maths. Binomial theorem is Vedic maths. Decimal system is Vedic math. The, so many of the things, I think I had given a list last time. So many of these
Yeah,
things which
yeah.
you're using today are already Vedic math. So it's not some old, abstruse, strange thing which you have to do separately. It is what you are doing. You just have to recognize those roots. And that is why I'm emphasizing the names of these mathematicians and their contributions. So I think what I want to do now is to tell you exactly how and what was stolen.
So just to have put a timeline, so calculus in India, so does it originate at the time of Aryabhat or his disciples or the Kerala school, or does it precede even that?
No, so actually, what is the thing is that there are roots from which Madhav and Nilkant did a
Mm.
lot of work on that. So what we can say is that right from the time of Aryabhat, so Aryabhat had given sine and cosine tables of I think 24 angles from between 0 and 90 degrees. Yes.
Okay.
So in his book called Aryabhatiyam, there was a table of sines for 24 angles between 0 and 90 degrees. This was in the 5th century. This is verse
Mm-hmm.
12 of the Ganit Pad section of his Aryabhatiyam. This verse gives this table of sines, but it also could well give the fundamental theorem of calculus. If you want to read this, or if anyone else wants to read this, because it is actually a lot of tough math, you can see the appendix in the book called The Imperishable Seed by Bhaskar Kamble. So, what the answer to your question would be that from the 5th century, to about the 13th, 14th, 15th century. So that's what, about 1,000 years. So the development of this kind of calculus, which is finally used and which went to Europe, took about 1,000 years in India from the 5th century.
I see.
Whereas,
Okay.
and yeah, and how it happened in Europe, I think we're going to look at that also.
Yes.
So we are right now in the 15th century. So there are lots of problems in Europe about navigation, about the calendar. They are just unable to do a lot of things. So in the time after 1582, I told you that it was around this time that the first batch of, sorry, 1578. Note this year. It is 1578 of the Common Era. This is the time the Jesuits first arrive in Calicut. And they were secretly sending translations of Sanskrit to Portugal, and then from Portugal to Rome. So I told you about the Portuguese Pedro Nunes. He was one of the conduits. Again, I must tell you something. Yes, I think so. In his book on whether or not, George G. Joseph, the person who wrote The Crest of the Peacock, and later he wrote a book called uh, A Passage to Infinity, Medieval Indian Mathematics. He has said that I have carried out an analysis of this transmission, and I am not really sure whether it happened. It's a very strange kind of book. I just read it yesterday. First, it gives you all the evidence about how the transmission must have taken place and what was set up for that transmission, the conduit. And he also says what are the three principles that we should consider. And then suddenly, strangely, at the end, he says, no, but I am not convinced. So what
Okay.
made him not convinced is very difficult for me to know. Other mathematicians, including Bhaskar, Kamble, have used the evidence and have given very clear conclusions from the same evidence. So what happened to him while he was writing A Passage to Infinity? I don't know. Since he was a mathematician in Britain, in I think University of Manchester, maybe there was some kind of pressure brought to him or whatever. However, that book is an interesting one for anyone to read because, to be fair, he does give a lot of information. You can use those facts to arrive at your own conclusions. You don't have to look at his conclusion. Read the facts, arrive at your own conclusion. So you had asked me a question right at the beginning, Utkarsh, that if there is a well-documented history of maths, which goes back 1,000 years and tells you that this is how calculus was done, why don't people accept it? But unfortunately, it's not as simple as that, because we are talking about 1,500 years here. We are also talking about translations, manuscripts, some of them have gone missing. And also we are talking about the secrecy of the church. Because again, remember, this was the time of the Inquisition. Anything which you sent from a pagan land, especially formulas and mathematical equations, could be very well misinterpreted and it could be off with your head. So this was done secretly. So when people say that we can't find manuscripts and evidence, it's a little difficult because of the time, because of the nature of the church, and because of many things which were done to obscure all this entire process. And whenever huge amounts of time are concerned, you have to look at different types of interpretation. So let's look at Western historians of science. When they look at very, very long periods of time, what are the three principles they look at? Because exact manuscripts often are not found, and exact links often are not found. So what principles have they set down to understand what came first and what came later? Was there any transmission? There are three principles. The first one is time. Which one came first in which part of the world? The second one is, was there a communication route between the places where we say that transmission was taking place? And the third is, identification of methodological similarities between point A and point B. Are they there? These are the three principles that Western historians of science for one last 1,000 years have been using. So we will use these same principles. We have been using, and whatever I've said to you right now, we have used these same principles. I have told you the chronology, which starts with Aryabhat, and that is documented. You have his books. Then we come to the Kerala school. I told you about 15-20 names. The works of all these mathematicians is available. You can actually read those works and see what is written there. Now, identification of methodological and other similarities. So now I will tell you about these wonderful coincidences which happened. 1578, the Jesuits first came. 1582, 4 years after that, there was a mathematician called Clavius and another one called Lilius. They proposed the reform of the Julian calendar just 4 years after that. They had been floundering around, not able to do anything, but they did it in 1582. Then, Neelkant Somayaji, I had just mentioned him. In 1501, he had written a composition called the Tantra Sangraha, and he gave a model of planets. Exactly the same model was proposed in 1588 by Nicholas Bayer and, sorry?
No, go ahead. Yeah.
So exactly the same model was proposed by Nicholas Bayer, and his work was, contrasted with that of Tycho Brahe. So both Tycho Brahe and Nicholas Bayer. Tycho Brahe is a very famous person. When I was studying the history of science in my postgraduate classes, Tycho Brahe used to pop up everywhere. So just 10 years after the Jesuits arrived, Neelkant Somayaji's planetary model was presented by Nicholas Bayer and Tycho Brahe. Neelkant Somayaji lived between 1443 and 1560. He was the direct pupil of Madhvacharya. Not direct, after a couple of other people. This is coincidence number one. Or rather, this is coincidence number two, because the first one was the reform of the Julian calendar. So the establishment of the Gregorian calendar, which as we know, is still not accurate. Now, number three. Coincidence number three, trigonometric functions. So I told you that right from the time of Aryabhat, sine and cosine tables have been created. The Kerala mathematicians, especially Madhav and Neelkant, took it to unprecedented levels. So for Madhav, he did the table of sines for 24 angles in the 14th century, which were accurate up to 7 decimal places. And this whole thing was replicated by Neelkant in his own way. Now, in 1607, this Clavius I was talking about, Christopher Clavius, reproduced the same table in one of his works with no explanation of how he derived it or where he got it from. So, it was a habit of European mathematicians to not give credit to anybody else and to show it as something which I've done alone. It's flowering or something which I've done alone. This is coincidence number three. And we can roughly say that Madhav science series was kind of incorporated, taken over, copied, cheated, I don't know what word you want to use, by Newton. Newton claimed it as his own. Then there was also another one, remember, Leibniz? So Leibniz
yes, similar
took it
timing.
from, so Leibniz took it from what we found in the Yukti Deepika, which is a Malayalam composition of Neelkant Somayaji. It's not in Sanskrit, it's in Malayalam. So
why do we think Leibniz took it from here?
Because when he wrote it, they gave no explanation of, this was how I was thinking, this is what I have based it on, and this is what was my whole mental, what can I say? But the mental process, or the mathematical process, I should say, through which I arrived at this. It was like a sudden pop-up. Where did it come from? And remember, like I said the last time, at this point of time, by the 15th century, they had just barely accepted the decimal place value system and zero. They were struggling with fractions. So the jump is just kind of amazing. What happened? From where did they get it? The most suspicious part is that it existed already earlier in Kerala. And in Kerala, we can be a little more certain of the dates. Otherwise, if you go back 1,000, 2,000 years, you can't say this happened 1 year before this or 2 years before this. Here we can be
Mm-hmm.
certain because these mathematicians dated themselves, their birth time, and when they were writing these compositions. And if we can just hark back to one other podcast that we had done, remember the Kali Yuga timing that I was talking to you about? That Kali Yuga starts at
Yes, yes.
3106. So these mathematicians use that Kali time. They date themselves using that Kali time. So we know the exact date. So he has dated himself 10 years before Leibniz, 10 years before Newton. We know that there are people over there who are sending information back because we have those letters, that correspondence, we have all of that. We know the situation of European mathematics at that time when they were floundering around and not able to do things and looking for how to efficiently navigate, looking for how to efficiently make the calendar. When you put all these things together and remember those exact three things I was talking about, not principles of Indian historiography, but Western historiography: chronology, communication route, identification of methodological similarities. So, if we take these three principles, apply them to calculus, and see the and Utkarsh, even if we say that Newton and Leibniz did some similar things, so we can credit both of them with the discovery of calculus, they were not exactly the same. Whereas, if you see Madhav's sine series and Newton's, they are exactly the same. And if you see the Yukti Deepika and Leibniz, they are exactly the same.
Hmm.
So that is what makes this whole thing into a very clear case of robbery and thievery. Again, for the European side, we cannot see any background. We cannot see any progression that this was the seed from which the tree of calculus grew. Newton and Leibniz were just, suddenly very brilliant people. If you look at calculus in India, you can go back to the 4th century and you can see the sign tables in the Aryabhatiyam. In fact, perhaps you can even see the statement of the whole, calculus theorem in that particular verse number 12 of the Ganitpad section of Aryabhatiyam. You can see it there. That is how many years ago? 1600 years ago? Almost 1700 years ago? Aryabhatiyam. Therefore, you have roots, you have a base, you have a foundation on which all this was built up. That foundation does not exist in European mathematics. To be fair, Utkarsh, it may not be there in mainstream narrative today or popular culture or not even in that den of iniquity which is called Wikipedia. But mathematical historians are coming around to this view, and
Okay.
you will find a few of them who have written very well on all these things. So it's something which is slowly, the truth is coming out, and perhaps there are people who are ready to accept the truth now because the high noon of colonization is gone,
Hmm.
and the high power of colonization is also gone. The power of the church is also gone. So a lot of the things which had to be hidden don't need to be hidden anymore. So a lot of the structures that kept these lies in place are falling off. Therefore, a little bit of the truth is emerging. So therefore, we can see little glimmerings of yes, yes, calculus probably did come from the Indian subcontinent. So, I mean, I don't know how convincing did you find this whole set of facts and conclusions, or do you have some doubts? Maybe, we
See,
can see if
I
any
am
of those doubts can be.
so I am not. I have not read, or I mean, what I would, in order for me to have a informed view, I would actually have to read and compare the works that we said are, are very correlated to each other, from Newton, from Madhav, from Leibniz.
Hmm.
I'll have to actually read it and compare it. I don't even know if I'm qualified, with the assumption that what you're saying is true, that people who do understand it, have read both, have compared it, and have,
Yes.
you know, with that assumption, it's pretty damning. This is the
Hmm.
way I look at it.
Hmm. So again, for people who are deeply interested in this topic, do read The Imperishable Seed. It gives a very nice, racy,
Hmm.
interesting story, and also a lot of other papers which I will write in the description. So the whole
Yeah.
thing then, comes down to the fact that some people use their power for appropriation, and then appropriation in a very selfish kind of way. Because I don't think even I mean, I don't object to people disseminating knowledge and using it for the good of everyone. There's really no problem in
Hmm.
that. The problem, of course, lies in then obfuscating the source and then telling those same people from whom you stole it that you're idiots. You don't have a mathematical mind. You don't have a scientific mind. You natives can just do mystic things and think about God. You cannot do science and math. That was the whole thrust of the British Empire, British colonization, and it has had a debilitating impact on Indian science, which we will
Yeah.
consider at some other point of time. So that is the story of calculus. But
Yeah.
there are some other charges that are put on Indian math. That okay, maybe you knew a few things just here and there because you were doing some practical stuff. But did you really know it in a formal kind of way? Were you able to prove it? Euclidean geometry has so many beautiful proofs. Were you ever able
Hmm.
to prove anything that you said was true? Or was it just like throwaway things?
Hmm. I have a feeling I know the answer.
No, but the answer here is a little not that simple, Utkarsh, because the
Okay.
Indian way of proof is not the Western way of proof. There it is, there is something which you have to prove using certain axioms. That's not the method
Okay.
of the way, that's not the way Indians did it. Indians normally did something which was, derived from something else. There they
Okay.
said something. Then there was, suppose I was a mathematician who said something, who wrote something. Maybe I wrote the Aryabhatiyam. Then, oh my God, just imagine I wrote the Aryabhatiyam. No, Aryabhat wrote the Aryabhatiyam. And then there were certain bhashyas on it. Bhashyas are commentaries. In these
Okay.
commentaries, these things were explained. They were explained and the results were validated in these bhashyas. So if you just read the Aryabhatiyam, you would not get the validation. You would have to read a commentary, a bhashya for that. And there were other
Okay.
mathematicians who were writing these bhashyas. This validation is called pratyayakaran, that you are validating whatever has been written in that shlok or sutra, you are validating it. Then after that, then you demonstrated them. This demonstration is called upapatti. This upapatti is what you can say is the Indian method of validating, or the Indian method of establishing or demonstrating that some mathematical proposition is true. So it's very different from proof. It's a different way of operating. So what is the, I've been talking about Aryabhat. So Bhaskar wrote a bhashya of Aryabhat and Aryabhatiyam. A lot of the things that Aryabhat said were validated in this bhashya. So if you read Bhaskar, you will be able to understand the validation. Now
So why doesn't
Bhaskar,
someone like Aryabhat? right validation to begin with?
I see that is because there is a very peculiar system or peculiar, what can I say? There is a goal while you are composing a Sanskrit text. That goal is brevity. Brevity
Okay.
was, it was valued above everything else. There is a very sarcastic shlok which says that for a Brahman who is writing a shlok, he would rather shave off 2 syllables or 3 syllables from his shlok than have 2 children. So he would value the shaving off of those syllables more than his children.
So how do you
So
pack
this
as much meaning as possible into as little
yes,
space?
yes. And this actually has become a problem for us because we no longer understand those principles of how it was made precise. So many layers of meaning have to
Of
be
course, yes.
unpacked.
I completely
Many
understand now.
layers of
You
meaning
need a
have to
little bit
be
of an
unpacked.
understanding of context and how, otherwise, you need a little bit of a code to understand it fully.
Yes. In fact, you need a lot of code. You need a lot of
Yeah,
understanding.
absolutely.
I'll give
Yeah.
a mathematical example. So, mathematicians, when they were writing mathematical treatises. Sometimes instead of numbers, they would say something else. Suppose they say netra, then you are supposed to understand it is the number two.
Hmm.
Suppose they say trivarg. So trivarg is dharma, arth, and kam. So
Yeah.
they will not say it so exactly. Suppose they say varg, then you know that there are three varg, dharma, arth, and kam. So that number is three. So like this, there is a whole set of words which are
Yeah.
used for certain numbers.
Yeah.
Actually, this is
I
also
mean, it's
points.
no. I mean, the company that I used to work in was famous for its what is it? Three letter. What's it called? When you have three letters. Forgetting the word in English right now.
Acronym.
When you have a acronym,
Yeah.
three-letter acronyms, right? And if you don't understand the acronym, if you read a business document, you'll have no idea what is going on,
Yes. It's
right?
the
So it's
same principle. Exactly. A very good contemporary example. It's the same principle. So it was brevity. And this has led to umpteen problems because today we don't understand them, we can't unpack them, we don't find the whole thing over there. Like you said, why didn't he write it himself? Why didn't Aryabhat write it? But that was not the system. The system was to
Mhm.
be, and again, remember, this was not just for some kind of misplaced priority. This was an oral tradition, remember? So somebody had to memorize those shlokas and
Yes.
sutras. So therefore, that was why there was this emphasis on brevity to make it easier for
I
the
think it's a
students who have to
yeah, yeah.
memorize it.
It's a different question, and maybe this is not the right podcast to get into it, but maybe it just struck me. The oral tradition is so much more difficult. Of course, it's more effective because if you truly remember it,
No,
you really
difficult how?
remember it.
Difficult how?
You have no reference point. Your reference point is in your head. If you have to
No,
remember a
sorry, I
poem,
don't
and
understand. I don't understand.
if you have the ability to write something down and refer to it versus having to memorize it, the former
Utkarsh,
is easier than the latter.
no, Utkarsh, that's because you've not trained your memory at all. Just
Exactly.
talk
I mean,
to
yeah, go
just
ahead.
talk to people who actually still use this
Hmm.
memorizing method and this oral transmission method. They have
Hmm.
everything at their fingertips the minute you ask them.
Yes.
Whereas you will who have to go back, I will have to go back to a reference library. Suppose I ask
Yes.
them that Yajurved, this Khand, this was written, what was it? I will have to spend a lot of time going back to those books. That person knows it immediately. It's a different question as to which is better, oral or written. In the Indian context, thank God we were an oral civilization. Otherwise, the number of libraries, universities which have been pillaged and burnt, we would have been left with nothing, Utkarsh. Absolutely nothing.
Do you think that
Foods
is
for
one
us.
reason why this is the one of the only Bronze Age civilizations that has
Yes,
survived because of oral tradition?
absolutely. Absolutely. It is because of that. And there are families who have been doing this for 2000 years. The temple priests who look after Chidambaram, they have an unbroken 2000-year-old tradition. And instead of
Wow.
celebrating it, you have all this terrible Brahmin bashing and trying to get them down. The current political dispensation is trying to smash them to pieces.
Mm-hmm.
So we don't
Mm-hmm.
celebrate our own achievements. So this
Mm-hmm.
brevity was the whole thing is all, it all comes together. Brevity
Mm-hmm.
means that a lot of information can be packed in a very small thing. Again, just an aside, look at Kalidas. Like I told you, he is supposed to be the premier Sanskrit poet and playwright. So Kalidas was famous for his compound words. He, in
Mm-hmm.
one word, you know that there is Sandhi Vichhed also, so you can make a compound word by putting a lot of words together. He would put a lot of words together. Those words would open up into a number of uh, constituent parts. Each of
Mm-hmm.
those would have more than one meaning. So from that one little thing, you can write a whole paragraph of the meaning. The very good example of this is in the opening verses of the Raghuvansham, when he describes King Dilip, who is riding a horse. So
Mm-hmm.
it's a small half of a verse, but when you open the meanings, it will become a paragraph. So
Mm-hmm.
Sanskrit poets and writers and even the mathematicians and scientists were in this whole, the system was of brevity. So therefore, we are going back to the mathematical proofs now after this very wonderful digression, very interesting digression. So these validations or upattis were found in the Bhashya, like I said, in Bhaskar's Bhashya of Aryabhat. So without
Mm-hmm.
this upatti, it would not be accepted by the community of scholars. It was, it was had to be free of doubt and confusion, validated by someone, demonstrated by someone, then only would it be accepted by the whole community of scholars. This is very different
Mm-hmm.
from proof. What is proof? It is the absolute truth. Here we are not talking about absolute truth. We are talking about demonstration and validation and uppatti so that it is accepted without doubt and without problem and confusion by the scholarly
Mm-hmm.
community.
Yeah.
So it is a bit like peer review. So you observe the
Mm-hmm.
results in many cases. Suppose you find the results to be the same in many cases. Still, this uppatti, which means demonstration, has to be there. You have to, they proceed from what is known to establish the results and move to the new results to be established. So it's a process of derivation. It is also a process of experimentation. So these were the
Mm-hmm.
methods by which Uppatti was done. Uppatti is different from proof. It is a different method of validation and understanding and epistemology, basically. It is a different means of knowledge. Proof is more axiomatic, absolute truth. Again, Utkarsh, can you see the difference between a kind of monotheistic religion with one truth and something
Mm-hmm.
like Sanatan Dharma, which has a whole panoply of things that people believe in? That difference can be seen very easily in this. So tark or
Mm-hmm.
argumentation was also used, but it was seen as a proof by contradiction. Tark is proof by contradiction. It's there, but it's not an independent praman. If you do it only by contradiction, it did not work. Now, I'm saying all this uppatti and all. Please don't think that it's my original work. Not only is it not my original work, it is very much there in a series I would ask anyone interested in this topic to listen to. So there is a series of 13 or 14 videos on ancient Indian mathematics, which has been issued by, I think, IIT Madras. So
Okay.
it is there on YouTube. Just Google, it's either IIT Madras or IIT Kanpur. Professor M. D. Srinivas, Professor K. Ramasubramanian. They are two leading luminaries of unpacking ancient Indian math from Sanskrit origins. So if you find any of their videos, watch those also. Professor
Okay.
K. Ramasubramanian is just fantastic. Actually, so is Professor Srinivas. I've also heard his lectures on linguistics. So this is from that particular series on ancient Indian mathematics. I'll put the link in the description. So you see how it is different. The concept of
Hmm.
axiomatic proof does not exist. It is actually something completely different. And it goes back to actually the philosophy of math. Do we have 5 more minutes, Utkarsh, or should
Yeah.
we?
Let's do. Let's talk the philosophy of math.
Yeah, just a little bit. Now, we know that the basics of Indian philosophy is that there is Atma and there is Paramatma.
Hmm.
So the Atma is, is there is someone who observes and someone who is the observer. So
Hmm.
someone who is the observed. What is observed? That
Observe
is a
and observe. Yes.
observed and observer. So who is,
Observer, who's
huh?
looking and who's getting looked at. I mean, we're getting observed.
Yes.
Yes.
So who is the observer? Observer is the impartial witness to everything. That is called Brahman. Please don't confuse it with Brahman. It is Brahman without the A. Okay.
Okay.
So Brahman is the observer, the impartial witness. That is also called Par. So that is one part. Second part is observed. What is being observed? All of us: physical universe, matter, space, energy, our emotions, people, mental and intellectual activity, etc. All this is getting observed. This is called apar. So par is that who is observing, that is the observer, and apar is us. We are getting observed. So this is also called Kshetragya for the observer and Kshetra for the observed. You will find all this in the Bhagavad Gita also. So then you see
Okay.
there are two types of Vidya. Vidya is, what is Vidya? It is knowledge and learning. What is Vidya? One type is Apar Vidya and the other is Par Vidya. So what
Okay.
is Par Vidya? Par Vidya is basically, if I put it in simple English for viewers, it is to attain Akshar, to attain God, to attain Paramatma or Brahman. Okay, that is called Parvidya. That is
Hmm.
all in the realm of, that is mystic, that is religious, for lack of a better word, although it's a bad word. So that is
Yeah.
trying to understand Paramatma, the creator of the whole universe, or whatever you want to put it. The other one is Aparvidya. That's us, people living on earth. What is Apar Vidya? So, Apar Vidya is Vedang. Par and Apar are different because Apar Vidya is the natural world, the mental world, the physical world. So, things like maths, medicine,
Hmm.
linguistics, all this is Apar Vidya. Okay, so this is the difference between Apar Vidya is what today you would understand as different subjects, including the scientific subjects, psychology, sociology, everything.
I mean, upper just sounds to me like what is material in a way.
In
What
a
is
way,
what is
yes. In a way, yes, Utkarsh, but it also includes our mental processes.
okay. Okay.
So it won't be
Which
completely,
which I
our
guess some would
intellectual
argue is
activities.
can be material as well. But yes, I get what you mean.
Yeah. Emotions, thoughts, intellectual
Yeah.
activities, all these things. Now, in Apar Vidya, there are natural sciences, art, craft, maths, linguistics, surgery, etc., etc. And you do know that we have a very detailed classification of the 64 arts.
Hmm.
What I want to emphasize here is we've seen the difference between par and upper. However,
Yeah.
these are actually the same. Why are they the same? Because in Indian philosophical thought, par and upper are one. They simultaneously exist as fragmented into the individual Atma, but are also Paramatma or Brahman. It is only
You will have to
Maya.
repeat. You'll have to repeat that sentence for me. Sorry.
Okay.
I think a lot was packed into that one sentence. Just say it again. I
Yes.
think I got it, but just say it again.
Okay. So now par is the observer, apar
I
is
got what
us.
part enough. Yes, yeah, I
They
got
are
that.
both the same. According to Indian
Yes.
philosophical thought, they are both the same. And they are same in a very peculiar kind of way, which is beyond the ideas of physics. So they
Okay.
simultaneously exist as fragmented into individual Atma, but the main big Paramatma also exists. The fragmentation and the whole both exist at the same time. Why
Okay.
are the
Okay.
fragments perceived as us? We perceive ourselves as people. They are perceived because of this philosophical concept called Maya, which means that nothing is real. We only perceive it to be so. Once the veil of Maya is removed from our eyes, we will realize that we are the same as Brahman or Par. Does
Okay.
that
I
make it
got
a
it.
little clearer? Okay. So,
Yeah.
can you
I think
see?
I'm familiar with the idea, though not
Hmm,
expressed exactly in this upper
yeah, yeah.
distinction.
You would
Yes.
be because it's a basic thing of Indian philosophy. And does it
Yes.
remind you also of wave particle duality? Does it also
That
remind you of Schrodinger's cat, simultaneously
you can
dead and alive?
simultaneously. Yes, of course.
See?
I
So,
think the thing that I have found most fascinating, and I wonder why, and I'm sure people smarter than me have thought about it. The whole principle underlying what I mean, in today, of course, it's underlying all the quantum computers that we're thinking about, that observing something affects the behavior, right? The observation of,
yes.
so I mean, isn't that a direct interaction of quote unquote consciousness with physicality?
Mm.
Like, to
Yes,
me, it
yes.
sounds,
Yeah.
I don't know if I'm not a scientist, but it was just to my very naive mind.
Mm.
To me,
And
all of this is so
there
similar
is
to, I mean, yeah.
there are some papers coming in which are now saying, I read something day before yesterday that they found a link to universal consciousness, that the human mind has a link to universal consciousness. So this is something that Indian philosophy has
But
been saying for.
but anything to do with consciousness is not verifiable. No? You can only be only thing you can verify is your own consciousness. Everything else could be an illusion,
That's
probably.
a very good question because a lot of people are doing a lot of work on consciousness. Let's do a podcast on consciousness, and especially with the whole angle of AI and consciousness. Let's do a podcast on that.
Okay, yeah, we should.
It's a good complex system. So anyway, to come back to Par and Apar Vidya, in the
Yes,
Indian
yes.
philosophical and epistemological and pedagogical universe, Par and Apar Vidya go hand in hand. For example, math is there for very practical things also, and also, say the Sulba Sutra to make that altar, that Yajna with which you
Hmm.
will worship
Yeah.
Brahman. So it is important to every field of human endeavor. So there's a very interesting Sanskrit shloka. Of course, I will not say it. It's very, very long, but it is by Mahavir in his Ganit Sar Sangra. And he gives a nice description of the kind of things for which math is important. So this verse from the Ganit Sar Sangra of Mahavir, it tells
Yes.
you that math is useful for everything under the sun, and it's a
Hmm.
beautiful description. I will maybe put it in below the YouTube video, and maybe you can read it. So you see that everything in the three worlds, whether it is earthly, Vedic, for meditation, business, cooking, love, economics, statecraft, music, medicine, architecture, this is from that verse. For everything
Hmm.
you need math. So, practical approaches for solving difficult problems for which there are no solutions in closed form. Therefore, you need approximation, you need interpolation, you need extrapolation. So, this is where it also differs from Greek math, because for Greek math, approximation is an insult. Approximation is something unthinkable. That means you've just spoiled everything if there is approximation. So these are the difference between the philosophy of Indian math and the philosophy of Western math. And it's important to understand this because it has an impact on all the work that is done. This is the reason, this philosophy is the reason why math has evolved in India the way it did.
Hmm. Yeah. I think it would take much more of a mathematical understanding, and I think I would have to read up much more to truly appreciate the differences, right?
Yes. But if
Yeah,
ever you are actually interested, you watch those 13, 14 videos
yeah. I think I'll
that
start
I
there.
was talking about. Yeah. If
Yeah.
you start over there, then, it's very, very illuminating. That was the first
Hmm.
thing I watched about 10 years ago. That is from where
Okay,
my
it's that.
interest in the history of mathematics started.
Hmm, 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 hmm.
And Utkarsh, there's a Ranchi connection to this. The most uh, illustrious historian of mathematics, T.A. Saraswati Amma, she comes from Ranchi University.
Oh,
Yes.
okay.
Yeah. She did pioneering work in geometry, the history of geometry and the Sulba Sutras. And I'm very proud that she was a professor in Ranchi University. And some of her students are the other illustrious historians of mathematics. So Ranchi is firmly on the map as far as history of maths is concerned.
That's not a bad thing at all.
Yeah. We are
Maybe I
proud
should
as
then,
people who have connections with Ranchi. We are proud.
yes, and maybe we should live up to the mathematical connection. At least I should.
No, I am very inspired by T.S. Saraswati Amma because I do a lot of work in the history of math and science. I am very inspired by her.
Hmm. Yeah. Good. Again, I mean, for me, such a, I knew that we were going to have a conversation with which would have a certain level of proof, of course, but the very fact that you have works happening in India and then being copied 10 years later by whatever the period is by Newton and Leibniz was just mind blowing.
Yeah,
And
it
I mean,
is
Newton
mind
is the
blowing, and
darling of, yeah,
yeah, yes, Newton is a darling of Western science, right from the apple which fell on his head to everything else.
yeah. I'm pretty sure if I go right now and have a conversation with anybody, that so many people that I know from the West, and if I tell them this, they'll be like, you sound like some sort of mad hatter
Conspiracy
guy
theorist,
with a
yeah.
tinfoil hat conspiracy theorist.
Yes, Mad Hatter is the right word. Yeah, Mad Hatter, conspiracy theorist, or maybe
Yeah,
some kind of fascist, nationalist,
yeah,
supremacist,
yeah.
whatever. Unfortunately,
One,
Utkarshan, you are very
yeah,
right that these labels will be put, and by putting these labels, certain what can I say, facts are sought to be hidden, because once these words are
yeah.
thrown at you, you may just keep quiet, not say anything more, and that keeps certain
Hmm.
facts hidden.
No, that's for sure. I mean, the easiest way to shut something down is to accuse it of
Yeah,
being something immoral. Then you shut
and
something
wrong. Yeah,
somebody down, right?
yes, 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 yes,
Right.
yes,
Yeah.
absolutely.
Good, but yeah. So a lot. I mean, a lot of material as well to be seen after this. I think I'm going to check out that 13-part series.
Yes.
Uh, yeah, that should be interesting. And I think I definitely need to get down to reading the two books that you keep mentioning. The
Utkarsh, I would
Imperishable. Yeah.
definitely suggest
Yeah.
the series, the YouTube videos. They
Hmm.
are very well done, and there's somebody who's explaining everything to you very nicely.
Hmm. 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 Yeah, better to watch that than your usual
Yeah.
sitcom while eating lunch, I guess.
Yes, absolutely. And of course, the Imperishable Seed, the Crest of the Peacock,
Crest of the
and
Peacock.
C.K.
Yeah.
Raju's works, all these are all very, very good sources, very good sources. I will put a few more. This time, the description is going to be very source heavy, but to
Hmm. Hmm.
start with, these will do. Utkarsh, we've really gone down a heavily mathematical lane this time and the last time. Next time, we
Hmm.
have to do something really frothy.
Okay. What do you have in mind?
I don't know. I can never think of frothy stuff. My mind
Okay.
only wanders around these corridors. So I can never think of frothy stuff. But perhaps we should do something a
One
little
thought that
light.
I had is that ever since we started doing this podcast, I keep seeing everywhere in the movies that I watch and the TV shows that I see, I keep seeing inaccuracies, things that irritate me, that did irritate me previously, right? Because, just
Yes.
certain way certain historical things are taken for granted, this and that.
Utkarsh, that's because
Young
now you
Sheldon,
know. You cannot
young
not
Sheldon.
know. Young Sheldon, praying to zero.
So, what we should do is sometimes we should just compile all these things together and just put it
Yeah.
and maybe just give some perspective. That could be
I
one
may
more
just
frothy thing.
explode into a puff of smoke if I start compiling these because they'll make
Yeah.
me so angry and there are so many of them. But
So I'll tell
maybe
you.
it's, yeah.
So I don't know if you know this, but in the US, there's a conservative commentator called Ben Shapiro.
I think
I
I
don't know if you've heard of
vaguely
him.
heard of him. Yeah, I
He's a
vaguely
Jewish
heard of
guy,
him.
very strong opinions. Of course, he strongly believes in the superiority of the West. But
Hmm.
there'll always be certain things on which you will agree with him, right? He's more into family values and stuff like that, against a lot
Okay.
of stuff that's happening in America. Anyways, the point is this: one of the most fun things to watch is he reacts to hyper woke TikTok videos
Okay.
because he is very opposite of woke, and it's just
Yeah.
really funny to watch. So maybe you should do a little bit of that.
Yeah, maybe, I can react to these Western historians.
Yeah, something on those lines.
I may just become incoherent with anger, Utkarsh.
That's the funny part. That's what people
Unable to
watch reaction
speak.
videos for. Yeah. Okay. Wonderful. Should we end it here?
Yes, I think so. And whether or not I become incoherent and speechless, I will see you next time with something interesting.
That's always the promise. All right. Take care, everyone.
Namaste and see you again.